Welcome back to this series of lessons on programming skills for A-level computer science. In this lesson, you'll learn some strategies for debugging your code. So in this lesson, we'll look at some strategies you can use to make sure that your code has as few errors in it as possible. We'll review the types of error that can occur in programs and look at ways that you can find those errors so that you can fix them. And finally, we'll review some of the features of the IDE, the Integrated Development Environment, which will help you to find the bugs in your code. A good way to write bug-free code is to work in gradual steps. If you sit and try and write an entire complicated program in one go without running it, it's extremely likely that there will be errors in there somewhere. So I suggest that you break a difficult problem down into several smaller problems and perhaps write those as separate programs that you can get bug-free and then put them together. Also, as you build up a program, I suggest you write one part of it. Let's just say simply the lines that get the user input. Run that, make sure it works, and then perhaps add one or two other lines and run it again and work in that way until you've got your complete program. You can also try out different inputs as you're running that program during your programming task. Try different inputs to make sure that your code can cope with all the different circumstances. In this way, you will minimize the amount of bugs in your code and you'll find that your programming goes much more smoothly. However, problems will still sneak in, and it's generally fairly easy to spot that you've got a problem. For one thing, perhaps your program just won't run at all. Or it will run, and when you enter inputs, the program will crash. Or your program will run, it doesn't crash, but the outputs that you get are wrong, so you don't get the results that you're looking for. These three circumstances are three different types of error. If the code will not run at all, we call that a syntax error. Syntax is the name for the rules of any language. So let's say English has syntax, but Python and other programming languages have got a syntax. That's the rules of the language. So if you don't obey those rules, your code will not run at all. If your program runs but then crashes, we call that a runtime error. And if the program runs and doesn't crash but does the wrong thing, gives you the wrong answer, then we call that a logical error. Some people call it a semantic error. The two first types of error, syntax and runtime error, are easier to spot because we get error messages. With a logical error, we don't get an error message because the computer doesn't know what we're trying to do with our program, so it can't give us an error message. So that type of error is somewhat harder to spot. So examples of syntax errors: you might mistype a command, you might just misspell it, for example. You might use the wrong symbol. This is my single most common error when I'm trying to use the double equal symbol. That means that two values have equal value. I sometimes just type a single equal sign. And sometimes we might use the wrong name for a variable. That is, we call a variable by two different names in two different parts of our program. These aren't the only syntax errors, but they're good examples. And you will get a coding error appearing when you try to run your code. So when you press run, you'll get an error. It might appear in the code itself or it might appear in the shell, but it will be very obvious that something's gone wrong. Runtime errors won't show up when you try to run your code. When you press run, they'll happen when you actually start entering inputs so that you carry out your code. So don't be confused by that. You click run to start running your code. If there's a runtime error, it will happen during that process as the code is running and the user is entering inputs. The three most common sorts that you might come across are a data type mismatch. For example, you get some input from the user and you try to use it in a calculation without converting it into a numerical data type. You've got a loop, typically a while loop, but you haven't put any commands inside the loop that let the loop stop. And so the loop will just run forever. And finally, if you ever try to divide by 0, that will make a program crash. And mathematicians will know that any number divided by 0 is infinity, and the computer can't store infinity in its memory. So all of those will produce runtime errors. And typically, when that happens, you'll get some sort of error message which the user will see when they enter their input. Not always, but that is a good rule of thumb, that a runtime error will produce that sort of error message. And finally, logical or semantic errors. They're harder to define, but you might get the wrong output from your program, or the output might be unpredictable. So in some circumstances, you will get the wrong output, or the output is presented in a way that's not useful to the user. So in some way that doesn't meet the requirements of the problem. Much harder to define that. And really the only way you're going to find those types of error is by testing your program quite thoroughly, because there could be hidden logical errors. So, assuming that your code has got bugs in it, any relatively complex program will have bugs in it, at least at an early stage. Try to work in a way that prevents this happening. Preventing bugs is less work than finding and fixing them. So develop your code in easy stages. There's no point in being macho and trying to write loads and loads of code in one big go and then running it. No programmer will work in that way. Look out for the features of the IDE. I'm going to talk a bit more about those on the next slide, but that will help you to spot where you've got a code error. Apart from the error messages, do testing to identify any hidden problems that you might not have turned up, and then obviously fix any problems that you've identified, then go back to the top of this list and carry on working. I said that an IDE has got features that will help you, and this is something that does come up in the exam. The IDE is designed to help you to write clean code. There are a range of different editing tools available that will let you delete, edit, cut and paste, replace, and all these tools will help you to write your code. The text as it appears when you write it will be formatted automatically by the IDE. Different IDEs use different color coding systems, but for example, in using idle, which we use in class, if you enter a Python keyword, it's displayed in gold. So if you enter a Python keyword and it's not displayed in gold, it probably means you've mistyped it in some way. We've talked quite a bit about error messages. They'll appear either in the code window or in the shell, and they'll tell you that there's an error. And there are also some debugging tools, and I'm just going to talk briefly about those in the next slide of this presentation. There are three tools that they like you to write about in the exam. Idle and Python are really great programming systems that we use, but one disadvantage is that these three tools are not available in Idle. So you've just got to learn these three, and if you're asked to write about IDE tools or features, mention one or more of these. So you'll just have to learn these terms. Some programs offer you a step through that will run each line of the program and then wait for you to press enter before it goes on to the next line. So you're stepping slowly through the program. Other programming environments, not idle, offer you a trace feature, and that will display the value of each variable either throughout the program during a step through or at the end of the program, so that you can see what's happening to each one of your variables. And some IDEs allow you to set a break point in the program. At that point, the program will stop. It will sort of go on hold, and you can look at all the different values of what's going on in your program at that time. All of these will help you to find bugs in your code, but we don't have them in idle. So simply learn those 3 terms and be ready to write them as answers in exam questions. So let's just briefly recap what we've been talking about. We've talked about strategies for writing bug-free code. We've talked about the 3 types of error that can occur in your code, and we've described the features of an IDE that will help you to find and fix errors. So my Now You Try It activity for this week is actually just to continue with the programming challenges that I've set you, but now with a greater understanding of how to create bug-free code, either by writing code without errors or by finding and fixing errors in your code. All right, see you in the next lesson. Bye for now.